Sandeep Dabade is a solutions engineer for StarTree. Now, if you don't know what that means, it means instead of just talking about how things work like I do, he actually has to make things work for people who are paying money and have expectations. There's a lot of pressure there. And that means there's a lot of things he knows that are super valuable. Today, we're going to talk about capacity planning in Pinot. How big should a cluster be for a given kind of query and server? How much can a certain kind of machine process? All those kinds of things. It's so much practical information. Listen in on today's episode. Hello and welcome to another episode of the Real-Time Analytics Podcast. I'm your host, Tim Berglund, and I'm joined in the studio today by my friend and colleague, Sandeep Dabade. Sandeep, welcome to the show.
Thank you, Tim. Super excited to be on the show.
It's great to have you. We're going to talk about capacity planning today, but before we get into that, tell us a little bit about you. What do you do? How is it that you know something about Pinot capacity planning?
Sure.
Tell
Yeah.
us about yourself.
Yeah. I've been part of cloud and big data space for a long time. Joined StarTree more than 2 years ago now. In one of the founding solutions architects. I've done a lot of pre and post sales side of things, right? Working with different use cases across different customers to understand their use case and then translate that into a capacity plan for Pinot on Pinot side, and then also deploy and then onboard that use case successfully on Pinot.
Awesome. All right. So frame the problem for us. What's when you think of capacity planning? What's the task? Is this always for people who are running Pinot themselves? Does it apply to the cloud? And how do you think about it?
Yeah, I mean, so I think this is one of the first things that any company has to do, right? Like when you're building a use case on Pinot, you want to quickly understand like what does that translate into in terms of infrastructure footprint, right? How many servers do I need to host this and power my use case? So yeah, this is one of the key aspects, and there are quite a few things involved here in terms of coming up with a capacity plan. We'll talk about those shortly. What are the things that we consider as general rule of thumb as starting point, and that should help you get started basically initially.
All right. So what are those things? What do we
Sure.
how do we begin the process?
Yeah, so let's take a step back, right? Like Pinot is a basically OLAP database that is designed to ingest data in real time and provide millisecond latencies under high read and write throughput, right? And the Apache Pinot architecture is very smartly designed. It's decoupled architecture. Each individual component can be scaled independently as the need arises, and we'll talk about those needs. Sizing of each individual component is influenced by certain technical KPIs. So let's
Hmm.
quickly take a step back and understand what those components are, and then we'll jump into the technical KPIs if it makes sense. To start with, Pinot servers, right? Servers are like heart of the system. They do the heavy lifting, host the data, perform the compute on the data that they store. Then there is another component called controller, which is brain of the system, is what I call it. Keeps track of which data is sitting on which server, or which segment is sitting on which server. And a segment is nothing but a chunk of data that can be operated independently. Then there is broker, which is basically entry point into the read workloads or read queries that are coming into the system. Broker is responsible for scattering the query across servers and gathering the partial results from each individual server and doing the global aggregation and return the response back. And lastly, we have minions, which is a completely stateless component. It is designed for performing back office operations without impacting the ongoing workloads or queries. One such task, there is quite a few operations that can be done. One such task is like batch ingestion task that StarTree has built to bring in that batch ingestion or unify the batch with real time in Pinot natively through this task. So all of that can be done through Minion as a component.
And So that's a Pinot cluster: servers, brokers, the controller, and minions. Little zookeeper off to the side,
Yeah,
remembering things on behalf of the controller. But there you go. And those components are important because those are the things. When we say capacity planning, like you said, concretely, it's just how many instances do I need? What are the
right.
servers that I need? Now we're using server in separate senses there.
Yeah,
There's the general server and there's the Pinot server.
Pinot server.
But yeah, you want to know how many of these things. So you have to
Yeah.
know what those parts are since they scale independently. You may not, well, you're not going to need as many minions as you're going to need servers, um, and everything. And at this point, yeah, uh, keep going. How do we do this?
Sure. Yeah. So now let's look at the technical KPIs, right? At high level, there are three technical KPIs, right? One is read throughput,
Mhm.
second is write throughput, and then lastly data size.
Okay.
So when it comes to read throughput, like how many queries per second that you want to support, right? And this typically impacts broker sizing, which is the entry point into the read queries, like mentioned
Hmm.
earlier, and also server sizing, because servers are the ones that are actually doing the heavy lifting of processing those queries that on the data that they host. General rule of thumb when it comes to broker sizing is a 4 vCPU broker can host up to 200 read queries per second.
Okay.
And that's that should be a good used as a starting point for a typical OLAP query. Obviously every use case is different, query patterns are different, but this should work as a good starting point, I would say.
Yeah, I was going to ask that assumes some typical kind of query that's your basic filter and aggregate sort of
Correct.
thing that you'd normally do. So one 4 VPU server, you said 200 queries per second is what you should expect out of them,
Yeah,
given
that's
typical everything. Yeah,
that's right.
and it's interesting. I just want to observe when you say read and write throughput, we are talking about queries per second. We're not talking about like bytes or records or rows or anything like that. Again, given the assumption that the amount of data that comes back from an OLAP query is probably not much, right? This isn't
Yeah,
select star from a billion rows and give me all the things. It's give me a scalar or a group of key value mapping group by
correct.
kind of thing. It's usually not a lot of data. That's the whole point.
Right.
Is there's all this data in the world, and we're asking the database to make it small so that
Yeah.
there's a number we can look at. So basic parameters there. Just for anybody listening, queries per second. And again, that assumes this is OLAP, and OLAP means a particular kind of pattern. And if you do different things, you're going to get different results. See Sandeep after class. But given the typical everything, keep going.
Yeah. Yep. Yep. Yeah, and then a 4 vCPU server. We talked about the general rule of thumb for broker, which can a 4 vCPU broker can hold 200 read queries per second. On server side, it also, like I said, it also influences server sizing. A typical rule of thumb that we follow, or I would follow, is like a 4 vCPU server can host up to 100 QPS.
Okay, 100 QPS for VPU.
Yeah,
Wait, broker? You said say
server.
server. Okay,
Yeah.
okay, okay.
So now let's talk about write throughput, right? Like when I say write throughput, it is obviously we're talking in real time context. Uh, it can so yeah. So in real time context, write throughput means like what is the ingestion rate, right? How many events per second you are ingesting at the ingestion source,
Mhm.
and how many partitions do you have at the ingestion source? Pinot brings up one consumer per partition if you have replication factor of one, let's say, right? So
Mhm.
if you have, let's say, 16 partitions, will bring up 16 consumers on Pinot, and depending on the ingestion rate, uh, you would need to size your server appropriately, right? So it's,
Okay.
again, a general rule of thumb is you want to have at least one vCPU per partition, right? So let's say you have 16 partitions, you'll need 16 vCPUs. But if ingestion rate is extremely low, then you could have a 16 partition topic consumed on even a 4 or 8 vCPU server as well.
Right. And at the current state of consumers in Kafka, I know, so it's always like to mention the date. It's early October 2023 as we're recording this. There's some stuff going on about multi-threaded consumers and Kafka as a queue. There's things are happening where this might change, but the kind of basic, the way partitions and consumers work, you can't really have more than one consumer is a single thread thing. So the one vCPU per partition, you can't have more than that.
Right.
Okay, and that is so backing up again. We're assuming ingesting from Kafka, and clarity for anybody who's new to this part of things. Pinot spins up consumers, and it actually assigns partition or topic partitions to individual consumers on individual servers. It's not doesn't function as a consumer group, the normal thing where the cluster assigns partitions. It's like, nope, partition 1 is going here. I'm going to ingest it, and so it's a very particular thing to be discussed on another podcast. But yeah, go on.
Yep, and I think just to clarify as well, right? Like Pinot can ingest from any data source ingestion when it comes to real-time ingestion, be it Kafka, Kinesis, Pulsar, or PubSub. And then additionally, there is another factor, right? Like in a sense, the the data size. When it comes to data size itself, like you want to look at uh, what is your daily data size in terms of GBs, right? Then you want to look at what is your retention period. Typically, in a Pinot like OLAP system, you host your gold quality data on which you are doing some real time aggregate queries, firing those and getting those metrics, insightful metrics, right? So retention period can vary based on your use case. For extreme real-time use cases, retention period can be like 7 days or 30 days. And there are use cases that require retention much higher retention period. Could be 1 year or even longer, or infinite retention. So that also factors in, right? Like that, because that contributes into your total data size you want to host in Pinot.
Definitely, and that gets us into discussions of like tiered storage, which is a feature of StarTree Cloud. It's not an open source Apache Pinot thing, but when you've got long retention periods and lots of data, often the older data you can tolerate higher latencies, and so you'll put that in a cheaper place like S3 or something.
Yep, absolutely. And then so general rule of thumb when it comes to capacity sizing for accommodating data is like a 4 vCPU server can host up to 1 terabyte of data.
1 terabyte.
Obviously,
Okay.
yeah, 1 terabyte. Yeah, it can host and process data across that much of data. And again, like take it as a starting point, and then you can iterate. We've seen the deployments where we've gone like a 4 vCPU server with 2 terabytes as well, and things are fine. Obviously, there is a factor of query selectivity as well that comes into play. I'll talk about it as the next point.
Right.
But yeah, this should serve as a good rule of thumb to start with.
Okay. Those are actually good concrete things. So it's not terribly stressful to deploy a terabyte of storage onto a server like that. So that's good. Okay.
Yeah, and then now lastly, another factor is obviously number of segments. Again, number of segments is also derived based on how much data you're hosting. Typically in Pinot, a segment is a chunk of data that can be operated on independently. So more segments you have, higher degree of parallelism you have, right? But then again, it should not be an overkill as well. Too many small segments can also cause
Right.
issues there, right? Like in
So
terms of.
do you tune segment size typically? Is that a thing that you're also looking at?
Yeah.
Okay.
So typically, like typical recommendation is segment size between 100 MB to 500 MB, right? And then make sure to have segments within that size range. And so now number of segments, how many segments we are hosting in Pinot influences like like how beefier you want your controller to be, because controller is actually doing that segment to server assignment and doing a little bit of uh,
Hmm.
no, I wouldn't call it heavy lifting, but it kind of gets influenced by number of segments you are hosting. So uh, and again, general rule of thumb is when you're sizing for controller, if 4V CPU controller can support up to let's say 10K segments, right? And again, it's a simple rule of thumb it is, and we can always iterate based on like what you see in the cluster, but that should work as a
Got it.
general rule of
And
thumb.
in terms of scaling of the controller, it can be redundant for availability, but that does not scale out, right? So you could only
That's
scale that
right.
up. Okay.
Yeah, exactly. So
All
that's
right.
another, good
So it'd be
point
an upper
actually.
bound on what you could do with a single Pinot cluster would be
Right.
controller scaling. All right.
Yeah.
All right.
And lastly, there are a few external factors, right? I mean, two of them. High availability, right? Typically, a production sized cluster, you definitely want redundancy. Mostly, we're talking in context of cloud, where you're deploying in a virtual private cloud. So VMs can go down, and you want to make sure you have enough capacity to serve your workloads, even if let's say server restarts and things like that.
Yes.
Yeah. So typical recommendation is go with a replication factor of 3 when it comes to your VMs,
Okay.
and also the segment size. I mean, number of segments, right? Like, or rather, replication factor of segments. That should be also uh, uh, at least 3 replicas in the server, so they can be spread across multiple servers. And at StarTree, we are making Pinot AZ aware, so that each replica will is guaranteed to be deployed on a different AZ. So in case of AZ failure, you still have high availability, right?
To be clear on that, you say at StarTree, is that a thing that we're doing in our cloud product, or is that just there are folks at StarTree who work on open source Apache Pinot, and Pinot itself will get uh, data center AZ
Yeah.
awareness?
No, we contribute a lot to open source, right? Like we definitely take a hard look at a given requirement, whether it is for the enterprises or is it like it will benefit the uh, wider set of users. So we contribute to OSS Pinot. I think this AZ aware Pinot is something that we are deploying in open source, if I remember correctly.
Okay. Okay. Yeah, it's always I always have to check when it comes to
Yeah.
things like that. Is this a roadmap thing for cloud that I'm not supposed to be talking about, or is there a Jira somewhere? And this is in Pinot. It's we need to be good citizens. We need to be very
Yeah.
clear about that. So cool.
Yeah, and then lastly, the types of workloads. Again, like the query selectivity that I was talking about earlier, right? You have high selectivity queries or low selectivity queries. Highly selective queries, you can accommodate a lot more of those queries in a smaller footprint, versus you have very low selectivity queries, which is that's what we are seeing like off late, right? Like Pinot has been predominantly used as a OLAP data store,
Hmm.
with generally speaking high selectivity queries or group by OLAP queries. But as we've introduced joins and opened it up, we have actually opened up Pinot for quite a few other use cases. So
And
we are seeing
and
that as well.
and you see folks with low selectivity queries scanning many rows, or even worse, returning many rows, um, and optimizing cases like that.
Right. Yeah.
And how's that go? I mean, where are the boundaries there? Um, Surely there are some cases where, hey, look, we're engineers in a OLAP database. This just isn't going to work well. But um, how? I don't know if you have any rules of thumb or numbers
Yeah.
you can share.
Yeah, not a number per se, but so we want to definitely want to make sure that you're using Pinot for the right reasons, right? The use cases that Pinot powers are really like user facing analytics use cases. So there is an end user that is sitting on the other side, waiting for a response, where your latencies are expected to be in milliseconds.
Mhm.
User facing being like uh, a lot of concurrent workloads coming in. So under high throughput, you want millisecond latencies, right?
Right.
So and it's a end user facing product, so it's a web browser that could be serving an application or a mobile app or a desktop application for that matter. So from that perspective, that client itself has its own limitations in terms of how much data it can process. And uh,
Right.
so so you wouldn't expect like billions of records to be returned by a system like Pinot,
Right. That
obviously.
that 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 would be weird. Um, and even for a transactional database, they'll do that. They're going to have paging, and they're good at fetching whole rows, and like all of that is kind of going with the wood grain of the system. But yeah, right, fetching billions of rows out of a database usually, can we do something else? Right? Are there Parquet files somewhere? Anything? I guess it wouldn't be Parquet then. It would be Avro. But yeah, something. What else? What else? I'm getting a lot of good concrete rules of thumb here, which is nice. So
Yeah.
you're not just talking in generalities. Now I feel like, oh, okay, well, that's how big a segment should be, and that's kind of how many queries per second this kind of server can do, and this is really good. How do you? What's this like in the real world when you're doing this with people who are actually trying to get things done? And before you answer that, the thing with people actually trying to get things done in my world, when I'm trying to explain Pinot to people for the first time. That's a
Hmm.
lot of what my team does. Um, the problem is it's this new thing, and new things are hard to understand. And Pinot's not so hard to understand, but it's still, you're helping people with something new. And so when you give examples, you tailor those examples to the task of the teaching that you're doing. In other words, the kinds of use cases I talk about are
Hmm.
always strangely ideal, because you don't want to be doing a lot of mapping of this doesn't quite fit, but we're going to try to do it anyway, because you don't have space in your mind for that confusion. You're already confused about the new thing, and we're just trying to help you through the new thing. So my examples, my use cases, any sample code, it's always perfect, right? Wow, this is the best Pinot use case in the world. And that's not because I'm trying to, make something look good that isn't. It's just that the cognitive process of trying to learn something, it's not time to be stretching.
Yeah.
But you have people in the real world who have problems that are good enough use cases for Pinot that they want to use it, but it's always a little weird. It's always a little mismatch. There's always little strange things where the tool does the job, but you got to how do you do it in the real world?
Yeah, I mean, so we have seen like a huge explosion of use cases that Pinot is powering. Like, I mean, one example is a feature store use case that we onboarded recently, right? Key value store, right? I mean,
Ah,
when we looked at the query pattern, we thought, should we take it or not? Like, we
right.
took a hard look at it, and then, but the query was very very high selectivity query.
Okay.
The use case needed support for upsert, which Pinot natively supports. Pinot is the only OLAP technology that supports upserts natively, right?
Mhm.
And the expectation was, just give me that particular one most recent value from the data set, and it's a frequently changing
Right.
intraday upserts
How
coming in.
big? How big was the row? How many fields and how many bytes
Oh, it was
approximately?
a wide column data set, about
Nice.
I think 350 columns in
Oh,
there.
good. Okay.
Yeah.
All right. Well,
Mm,
I can see why you might kind of scratch your head first and wonder,
yeah.
should we do this? But you did it.
Yeah, and then we actually took it up, and the technical KPIs that the use case needed, because it is a key value store being used by applications, extremely high P95th latency, like sorry, extremely low P95th latency, like
Yeah.
15 under 15 milliseconds, right?
Oh, wow.
Ingestion rate expected was like in thousand 10,000s, and read QPS or read QPS particularly was in also in thousands. Like, they wanted us to see if we can support like 5,000 QPS for read.
And super wide rows.
Yeah. And we were able to actually support this use case with a small infra footprint.
Nice. Well, you've got a blog post on this topic, and that's going to be linked in the show notes. And as a person who in the world is responsible for helping actual clusters get built and configured to solve actual problems, this is really helpful expertise. I appreciate you writing about it and showing up on the podcast. I know you've got lots more things in this area to share, and I think probably be back on the show for those in the future.
Sure. Yeah. Thank you so much. I mean, the blog post actually will cover all the KPIs that we talked about. It will talk about the general rule of thumb, and that can I think it is a 2-part series. So part 1 talks about the KPIs. Part 2 talks about a specific use case for which we've done the sizing. So will be I think that should work as a good framework to start with if someone wants to do the capacity planning.
My guest today has been Sandeep Dabade. Sandeep, thanks for being a part of the Real Time Analytics podcast.
Thanks, Tim. It's always a pleasure to talk to you. Thank you so much for having me.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.